Continuing on, today's lesson is called Trigonometric Identities. And an identity is the same thing it means in literature, right? In English class. An identity is something that you are the same as. So just like you identify with something, in English, a trig identity is two things that identify with one another, that are the same as one another. An identity is an equation that's true for all values of the variable in which both sides are defined. So understand, sometimes one side is undefined and the other side isn't. We are going to ignore that case. Okay, so as long as both sides are defined, they're the same at every value. Here's an interesting identity. The tangent of any angle is equal to the sine of that angle over the cos of that angle. Let's demonstrate. So I'm going to make a random between 0 and 360. I'm going to make an angle, I'm going to say beta is equal to a degrees. And then I'm going to go sine of beta, cos of beta, tan of beta, and then the sine divided by the cos. I'll refresh it a couple of times. Notice that in every case, the tan of the beta and the sine over the cos of the beta are the same. And so this is the first example of a trigonometric identity where wherever you see tan, you could replace it with sine over cos. You already know the reciprocal ones. They're just, do the reciprocal of sine, you get cosecant. Reciprocal of cos, you get secant. Reciprocal of tan, you get cotangent. But now we can also think the reciprocal of cotangent could also be thought of as cos divided by sine, right? Because it's the reciprocal of this one. These are identities. Every value that's defined works on both sides. Okay? Now, the first new identity I'm gonna teach is really, really important, is the Pythagorean identity. And it goes sine squared plus cos squared theta equals 1. And again, here's a random angle theta. I'm going to do sine of beta squared plus cos of beta squared. And I always get 1 no matter what angle I pick. Okay? So these two work for the same reason. Let's just explore how does this one have anything to do with this one? It looks like sine squared, cos squared, and 1 don't have a lot to do with this, right? But let's demonstrate where this comes from. So what I'm trying to say is the only one of these you would need to memorize is the first one, because the other two are pretty easy to develop out of the first one. And watch what I mean. Okay, so let's start with the first one. It says sine squared, I'm just going to say x, okay, instead of watching me type theta over and over. Cos squared x equals 1. Okay? That's the identity. That is true for every possible angle x. Now, what if I were to take everything in that equation? Okay, so let's copy this equation, and let's divide each term by sine squared x. Oh, I see what's happened here. Okay, sorry, I'm going to have to retype it. There we go. Okay, so, sorry. Let's take each term and divide by sine squared. Okay, so you get sine squared over sine squared plus cos squared over sine squared equals 1 over sine squared. Now, what is this? Sine squared over sine squared is 1. Cos squared over sine squared, well, cos over sine is cotan, right? So cos squared over sine squared, I can replace with cotan squared. And over here, 1 over sine, I know it's the same thing as cosecant. And therefore, I've just developed this answer right here. 1 plus cotan squared equals cosecant squared, right? So it's pretty easy to develop. The one in the middle, by the way, you would just divide all the terms by cos instead of dividing by sine. That's all. Okay? So pretty easy to develop these two if you can remember this one. Okay, so remember the one at the beginning. Now here it's asking us to factor. How do you factor when you have a cos? So what you can do here if you have difficulty is you can say let cos. This is what I teach my grade 12s to do anyway. You don't have to do this, but it might be helpful. Let cos theta equal c. Then you're really just factoring the equation 1 minus c squared. You know how to do that. 1 minus c, 1 plus c. And then at the end, I'm just going to replace cos theta again. Right? So 1 minus. Okay? And just do that. So there's the answer. So I like to do it this way so that I do not mix up what's being squared, and I don't remember, you're never doing anything to theta in this question. Theta is inside of cos. So you can factor thinking about cos, but you can't do anything with theta. Theta is inside of cos. And this is why I think it's easier if you just replace the whole thing with just the first letter. Okay? And then you could treat it like a regular quadratic, like you were back in that unit, do your factoring and get your answer. And then you just stick it back in at the end. Right? So let's try the next one. Again, let's do the same substitution. Let cos theta equal c. Therefore, what is this question asking? C squared minus c plus 1. How do you factor that? I need two things that, multiply to 1 that add up to negative 1. And I'm going to go ahead and guess that there's an error here because I don't actually think that's solvable the way it is. Yeah, you can't factor that. So let's change the question to have a 2 in it just so it can actually be factored. Otherwise, I'm not sure what we're supposed to be doing here. But so let's change it. So 2c plus 1. Okay, now that, you know how to factor that. It would be c minus 1 and another c minus 1. And then you just give your answer again. Cos theta minus 1. Cos theta minus 1. And you've just factored it. Try to think of cos theta, the entire thing, as one variable. Theta cannot be separated from cos. Okay? Here, cos theta minus cos squared. Again, this one we don't even really need to do the c thing, but you can if you want. I factor out a cos theta. I'm left with 1 minus cos theta. Again, you can use the c method if you like it. You don't need to. Whatever you want. Sorry, it shouldn't say equals. It's just it's multiplying, right? So you have cos theta times 1 minus cos theta. Okay? So again, just remember, you can factor these expressions as long as you remember that cos theta is all one blob. Cos, let me write this down. Cos theta try to think of cos theta as one variable. You cannot separate cos from theta because cos is a function. It requires something to go into it in order to have meaning. Cos of a blank, cos blank means nothing. Cos must have something inside it. Must have some kind of value inside the function. Otherwise, it doesn't mean anything. Okay? So you cannot take theta. You're almost never working with theta in these questions. You're always working with cos theta. Like, try to think of cos theta as one object. To prove that an equation is an identity, show that one side is equal to the other side. You must treat the sides independently. This means you cannot add or you cannot move things across the equal sign the way you normally would in an equation. Okay? So for example, what on earth? In a normal equation, if this were if this was okay, so it says prove, right? If this were an equation one thing you might think of doing here, and again, I'm just going to replace it with x to make it a little easier, okay, to write. One thing you would do here is you could say divide both sides by cos. Right? You could do that, and then you would know that your identity on the left is tan x equals tan x, and you've shown that the two sides are the same. However, you can't do this. Okay? I'm going to put a strike through this, or yeah, strike through. You can't do it that way. Okay? When you're doing a proof, it must be set up in the following manner. Okay? So let me just show you how I want this set up. Make yourself a table. On the left, say left side, or LS. On the right, say right side. Write down what's on the left side of the equation. On the right, write down what's on the right side of the equation. Oops. Okay? Now, you are only allowed to work with what is on your side. You cannot shift from side to side, and you are trying to show any step on the left side is the same as any step on the right side. Okay? Now, looking at this identity is a very simple one to get us started. The left side is just sine. I'm probably not going to be able to do anything with just sine. I'd have nothing to work with. On the other hand, on the right side, I do know that at least tangent can be written as sine theta over cos theta. That's one of my identities, right? So instead of tan, I could say sine theta over cos theta, and then I'm multiplying this by cos theta. The two cos thetas are, one is being multiplied, one is being divided, so I get sine theta as an answer. As soon as I see that one step from here is the same as the step from here, I'm finished. I say, and then underneath I say, therefore, left LS equals RS, and the identity has been proven true. Okay? Again, you can just say LS equals RS. You don't need to write that full sentence, but I'm just going to write it in the notes. Okay? So that's how you do an identity. You make substitutions and changes and factor and cancel and do all your skills of algebra to try to show that one step from this side is the same as a step from that side. Let's try another one. Here you have cos tan over sine equals 1. Okay, so on my left side and on my right side all I have is 1. I don't think there's much I can do with 1, although one thing I could do is I could replace it with cos squared x plus sine squared x. I doubt that'll be helpful, but I mean, I can't think of what else to replace it with, right? I know I could replace it with that. The left side, though, I might be able to do something with. I know that tan can be replaced by sine over cos, so let's write this. Cos x over sine x, right, times, right? So I'm just sort of shifting the tan over there. I know I'm allowed to do that because it's still multiplying. It's not like anything was adding here. So we can do this. Then I'm going to say cos x over sine x times, I'm going to replace tan with what I know tan is equal to, sine over cos. Now I see that this is just equal to 1, right? Because the cos and the cos cancel, the sine and the sine cancel, and I see that I get a 1 on this side, and I get a 1 on that side. Again, you just need to show that any line from the right and any line from the left are the same. Okay? Underneath, we'll just write the shorter answer. Therefore, LS equals RS. Okay, and we proved it. A couple more identities to try. Cos equals sine over tan. Okay, again, let me set up my proof table. Okay, on the left side, I have cos theta. Probably nothing I can do with cos theta. It's pretty simple, right? On the other side, I have sine theta, and then I'm going to write divided by tan theta. Okay? And I'm writing it like that because it reminds me that sine theta divided by, now remember, tan theta is sine theta over cos theta. And when you divide a fraction, it's the same thing as multiplying by the fraction's reciprocal. So we put the cos over here and the sine down there, and now you see that the two sines cancel, and you're left with cos. Okay? And you're left with cos theta, which is the same, of course, as what I had on the other side. So I've proven that the identity is true. Okay, how about this last? What else? What have they got here? Bunch here, bunch here, bunch here, and then some work. So I'm not obviously. I think I want to leave a couple of these for you guys to do and prove, but I'll make sure I do at least one from each section and one if it looks particularly tough. I don't know why it's having such a hard time grabbing that box, but anyway. Okay, again, the left side is just cos, so probably can't do anything with that. The right side I have 1 over cos x minus sine x tan x. Now, in identities, you often don't know what the first thing you should do is, so try something. If it doesn't work, don't erase it. Hand it in. Hand in what you tried. Even if you don't get the identity right, if you can show me that you tried two different things and both of them, you made some correct substitutions, you just ultimately couldn't find the answer, you can still easily get 3 out of 4 in an identities question just by showing me you know how to make moves. So don't be too preoccupied with getting it right. Don't be too preoccupied with erasing your work if you're not getting it right. Keep your work to show it to me, okay? Let's keep 1 over cos x. We could replace that with secant x, but often that's not useful. 1 over cos x minus sine x. Let's replace tan with sine x over cos x. Now, so far, this doesn't look too promising as far as helping us get cos x, right? But let's keep going and see what we can do. Now, I have over here, I have sine squared x over, I have that. Now, what you can notice here is that you have a common denominator. Both denominator. So both have a denominator of cos. That means you can just join the top together. 1 minus sine squared x over cos x. Sorry, the 1 should also be on top. Okay. Now, some people are going to get stuck here. I don't see what I can change. Remember, when you see sine squared, you know that cos squared x plus sine squared x equals 1. So what if I were to take this 1 and replace it with cos squared plus sine squared? What happens? Instead of 1, I'm going to write cos squared plus sine squared. So I'm just going to color this in. I shouldn't use orange because that'll be confusing. But I'll put it in blue because it's an identity. And now I see that, okay, cos squared, I'm adding sine squared and then immediately taking it away. So I get cos squared x over cos x. And when you have something squared over itself, You just divide, you know from exponent rules, you have two coses on the top and one cos on the bottom, so you just have one cos left. And that is the same as what it was on the other side. Okay, and so therefore we've proven that that identity is also true. Okay, you can see how these are starting to get harder though. There's a bunch of different things you have to know to be able to do this one. I think H would definitely be a good one to do. I'm going to leave G. I think F is also a really good question. Yeah, both of these are yeah, well, this one's pretty straightforward. I'll leave you E. Okay, I'll put a spot on the site for you to do E. So do on the site. I'm going for F. I'll do F. Okay, so let's work on F. So, oops. Okay. So for F. Okay, let's look at what we got. Sine squared over 1 minus cos equals 1 plus cos. Okay, now on the right side, you have 1 plus cos x. It doesn't really seem like there's much you could do here. You could replace the 1 with sine squared plus cos squared. But I don't actually see how that helps me, and it doesn't really make it look more similar to what the left side looked like. It kind of looks like a dead end. Maybe there's something else I can do here, but I don't really see it. Let's look at the other side. Sine squared x over 1 minus cos x. Now, on the top, I know that sine squared can be, so like in my head, I know that the right side only has coses in it. So the left side having a sine in it means I probably want to trade that sine. And I know that sine squared x plus cos squared x equals 1. So what if I were to just rearrange that equation for a second and say sine squared x equals 1 minus cos squared x. Now, you're allowed to move this identity around because this identity has already been proven, right? The reason you can't move things in your equation from left to right is because your equation hasn't been proven. And if you move things, you assume that it's true. This equation, though, is an identity we already accept as true. It was in the note, right? It was right back up here, right? And so you are allowed to move things around this equation. So when you move something in this equation, you can replace sine squared with 1 minus cos squared. Now, how does that help me? That helps me because if I think about this now, I can say 1 minus cos squared, cos squared x, okay? And then I'm dividing that by 1 minus cos x, right? What if for a second I replaced cos x with c? What would this look like? 1 minus c squared over 1 minus c, right? Now, factor the top. The top is a difference of squares, right? 1 minus c, 1 plus c, divided by 1 minus c. Well, everything is in brackets, so those two are good to cancel, and you're left with 1 plus c. 1 plus c is 1 plus cos x, and that's what the other side is. Okay? Really good one to practice. Okay, give it a try. I was going to correct this, sorry. Okay? Really good question. I'm going to leave this one. G, I want you to try it. H, I'm going to do just because H is a common denominator question. We haven't really done a good common denominator question, so we've only done one, and it was pretty easy. So let's do one that's a little harder. Okay, so on the right side, I have 2 tan x over cos x. I could try to, let's work with the right side, see what we can come up with. So 2, I'm going to get over cos x. I'm going to replace tan with sine x over cos x. And all of that is over another cos x, right? So you have that. So how do you do this? This is simply 2 sine x divided by cos squared x, right? Because you've got this, and then you're dividing by cos x, which is multiplying by 1 over cos, and so you get this. I don't think we can make it any simpler than that. It doesn't. I mean, I guess we could replace the bottom with. Yeah, sure. Actually, we could replace the bottom with 1 minus sine squared x, because for the same reason we did it on the other page. Cos squared can be replaced with 1 minus sine squared, and sine squared can be replaced with 1 minus cos squared. So that looks pretty good. It kind of looks similar to what we see up there. What's the other side look like? Again, for ease of algebra, let's go 1 minus s over 1 plus s, right? Just to make it a bit simpler for ourselves. So the common denominator is 1 minus s times 1 plus s. Okay, so let's look at how this would work. So I take my equation. Okay, this side, okay, needs a 1 plus s on the bottom and on the top to make a common denominator. Again, I'll just put that in a different color if I can manage this. Okay, that side needs a 1 plus s on the top and bottom. This side needs a 1 minus s on the top and bottom in order to make a common denominator. Okay, again, common denominator, just use a different color. Okay, so now we made a bunch of common denominators. Now, what is this? Let's simplify this. On the top, we have 1 plus s divided by 1 minus s squared. If you FOIL the bottom, right? It's just going to FOIL the bottom. So 1 plus s over 1 minus s squared. Subtract, and then we're taking all of this and we're subtracting. Okay, 1 minus s over 1 minus s squared. So we have that. Now, they have a common denominator, so I can subtract. Okay? 1 take away 1 is 0. S take away negative s is 2s. And on the bottom, I have 1 over s squared. Now, what was s again? S was sine x. So I have 2 sine x on the top and 1 minus sine squared x on the bottom, which is what I got on the other side. Okay? That one's quite a bit harder, right? You start to see how skills you learned earlier in the course come back in this unit in this way. The last one I'm going to do, I'll do D, okay? I'll leave the other 3 for you. So let me just write these down. Of course, if you can't solve them or if nobody does them, you just request it and I'll do it. But I'm just thinking, watching somebody do these is only so valuable. You've got to do on the website. You've got to do them yourself. I mean, I'm trying to show you the little tricks and skills, but watching somebody do them is only so useful. I'll do one more and then we'll call it a day. Okay, so do that one on the website. Do that one on the website. Do that one on the website, and I'll do this one. I'll just get these back together a bit. Okay, so we'll draw my proof box again. Oops. The bottom can be merged. Okay, so over here we'll go left side, right side. Okay, on the right side we have 1 minus cos. I'm just going to change it to x because why not? Don't need to use theta. Okay, so that's what I have on the right side. Now, I gotta say, it does not look like there's much I could do here. I could go 1 over sine x minus cos x over sine x. I could do the opposite of a common denominator. I could separate it out into two fractions. And then I can see that 1 over sine is cosecant x, and here is cotangent x. But it doesn't look like there's much else I could do. But hopefully I'll eventually get one of these three things on the other side. On the other side I have sine x divided by 1 plus cos x. Again, there doesn't seem to be too much I can do with this. So not sure if this is going to work, but then again, that's what Identities is all about. It's about trying stuff. I kind of notice in this question that I have half a difference of squares on one side and half a difference of squares on the other side. Now, ordinarily, I could just take this denominator, multiply it over to the other side, take this denominator, multiply it over to this side, and I see that both sides are equal to sine squared. But I'm not allowed to do that in a proof, but it kind of gives me a hint about what I do want to try. What if I multiplied this by the missing side, the missing part of its... Okay, sorry. Let's make this a bit easier by doing it this way. First, let's replace everything. S. Okay, let's replace it. So, just to make it a bit easier. Now, what I'm suggesting is, I know it would be nice if I could do the rest of the difference of squares here. So that's what I'm going to do. I'm going to make up a number and multiply both the top and bottom by 1 minus c over 1 minus c. Now, why am I doing that? I'm doing that because I kind of recognize that although I'm not allowed to bring it over, I kind of see the two sides of a difference of squares here. And I'm allowed to do this as long as I'm working with only this side, because I'm multiplying by 1. I'm multiplying by the same number, right? And that doesn't change the equation. It's still an equivalent expression. What happens up here? I get s times 1 minus c, and on the bottom I get 1 minus c squared. Okay? That's what I get. Right? You get 1 times 1 is 1, then a negative c, then a positive c, and then a negative c squared. Now, how does this help me? S, 1 minus c. Now I'm going to factor the bottom, which I guess I shouldn't have expanded it in the first place. I should have just left it like that. This step is kind of silly. There's no reason for me to expand it. I should have just left it like that. What does this help me do? Now I notice that 1 plus c, or excuse me, 1 minus c is on the top and on the bottom, and I get s divided by 1 plus c, which is the same thing as what I started with. So probably... Oh, sorry. So here's a good example, right? Like you, I don't always know how to do these when I start. I know some things I could try. What I ended up doing here was creating something, canceling it, and just going right back to where I started. So here, this is an error, right? So this is a dead end. So let's go back. So I'm going to leave it. I don't want to erase my work. I'm just going to write beside it. I'm going to write dead end. Go back to step 3. So let's go back to this step here. Okay? Now, instead of saying 1 minus c squared on the bottom and canceling, I know that s squared plus c squared equals 1. Therefore, 1 minus c squared equals s squared, right? So what I could do here instead, try and keep this on one page if I can, is so I know this is an identity, so let's just put it in a different color. So I have s 1 minus c divided by s squared, right? How does that cancel? 1 minus c divided by s. What is 1 minus c over s? 1 minus cos x divided by sine x. That's what the other side was. Okay? So just like you, I don't always know how I'm going to answer these things before I start. I just try stuff and hopefully try to make it look more like the other side as I go. Sometimes I hit a dead end and I just go back to where I started, or it ends up going nowhere. Don't erase that work. Write down how it went wrong or why it went wrong or why you're abandoning it. I'm abandoning this one because all it did is bring me back to my original question. It didn't help me. But the idea I had still worked. I just needed to kind of work with it in a different way, right? And I was eventually able to show that the two sides are the same. So that's what this work is all about. Don't hand in a blank. Try something. If it doesn't work, it doesn't work. You can still get 3 out of 4 or even higher depending on what you do because you're showing me you know how to do identities. Okay? There's a ton of extra questions here. Identities, it will be worth, let's say, 4 points on your test. So half your communication section, let's say, probably maybe 6 points. So, I think 4 is probably fair. You probably get, actually, I think what I've done in the past is I do 2 marks for an easier identity and then 3 marks for a harder identity. So, your communication section for this unit, probably most of it is just identities. Like, let's say out of 8 marks, probably 5 of them are going to be identities. One easier one and one harder one. So make sure you practice these, try them, post your solutions, ask what other people did, ask for input or help.